The first question was sent by she or he was asking about how to find the zeros of a function p of x equal to x power 3 minus 2x squared minus 7x plus 12. This is question 10 in tutorial sheet 5. So to find the zeros of the function, this is same as you are asked to solve this function when x power 3 minus 12x squared minus 7x plus 12 is equal to 0. So we are going to find the values of x that are going to give us the zero part of this, hence zero of a function. So I want to find the value that when I put here, I put there and there, I sum up, everything should give me 0, and hence it becomes an equation. So one of the methods you can try is by finding factors of 12. So we have 12. The factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So you can try either the positive part of 1 and the negative part of 1. You substitute in this and check if it will give you the 0. Then that value is the solution to that. I was trying and I found that 3 is a solution to that. So let's try picking 3. When x is equal to 3, we are going to have this is 3 power 3 minus 2 power 2 times 3 power 2 minus 7 times 3 plus 12. We don't know whether it is going to give us a 0. We are just trying. So this will give us 27 minus, this is 9, 18 minus 21 plus this is 12. Even here I don't know whether it will give me a 3. When you add this part, you are going to find 9, and when you add minus 27 plus 12, you are going to get minus 9. Hence the answer is 0. So x is equal to 3 is the solution of this function. Since we know that this is a solution, we can now use synthetic division or long division or remainder theorem to factorize the remaining part. So what we'll do is, we have found that x minus 3 is the factor of this equation. Then we'll say by synthetic division, I put a 3 here, then I'm going to have the factors 1 minus 2 minus 7, 12. The first thing is I drop this one. 3 times 1, I'm going to have 3. I add this, I'm going to have 1. This times this, I'm going to have 3 again. Negative 7 plus 3, we are going to have negative 4. This plus this times that, we are going to have negative 12. From here, when I add the 12, we are going to have a 0, meaning that we have no remainder here. So the quadratic equation, when you divide this into that, you are going to remain with x squared, the coefficient of this, plus the coefficient of this is 1, which is x squared, which is just x, minus our constant, which is minus 4. What we are saying is, when I divide x power 3 minus 2x squared minus 7x plus 12, I divide this by x minus 3. This is coming from here. I am going to remain with x squared plus x minus 4. There is no remainder, so this divided by this, you get this function. So I can multiply this. I write now this in product form. X squared minus 7x plus 12 is equal to, we do cross multiplication. Here the one will multiply with this and this will multiply with that. We have x minus 3 times x squared plus x minus 4. If I've not made any mistake in here, if I multiply this and that, I should get this equation this side. So from here now we have remained with this quadratic equation. We can solve, we can find the factors of this quadratic equation, and then we express this in factor form actually. Okay, I was trying to find the factors of this part. It seems very complicated, but what we can do is, since we are solving this when x is equal to 0, and we are when this cubic function is equal to 0, we have found that x is equal to 3 will satisfy this equation. So if this is equal to 0, then it is also must be equal to 0. These are the same thing. So this is equal to 0, and then we have x minus 3 times x squared plus x minus 4 should give us a 0. We have already found that when x is 3, from here we are having a 3. When x minus 3 is equal to 0, we have a 3. So x minus 3 should give us a 0. The other part is x squared plus x minus 4 should give us a 0. This is x is equal to 3. The answer we have found already here. This side, you just have to solve a quadratic equation as usual using completing of the square method, using a quadratic formula. X is equal to, our b must be -1 here, plus or minus the square root of the square of b minus 4 times, we have -4 here, our c, over 2 times 1. X is equal to -1 plus or minus, this is positive 16, 17 over 2. So the solutions at the end will get x is equal to 3, comma, x is equal to -1 plus the root of 17 over 2, and x is equal to -1 minus the root of 17 over 2. So that is how we solve, that is how we find the zeros of a function. These are the numbers that will make this p of x being equal to 0. Okay, this next question came from Kunda. He or she wanted to know how to sketch f of x is equal to x over x squared minus 3x minus 4. So the first thing is we need to find the asymptotes in this function: vertical asymptote, slant asymptote, and also horizontal asymptote. So to find vertical asymptotes, first we need to know where this function is undefined. And for us to know where this function is undefined, the function down here, x squared minus 3x minus 4 must be equal to 0. Then we are going to have the vertical asymptote. So from here we have to solve this quadratic equation. X is equal to 1 positive 3 plus or minus the root of 9 minus 4 times negative 4 divided by 2 times 1. So x is equal to 3 plus or minus, this will give me 8 positive 16, and then 16 plus 9, we have the root of 25 divided by 2. X is equal to, this will give us 5 plus or minus 5 over 2. So x is equal to 4 comma x is equal to negative 1. So these are the values that will make this function undefined, or this function is undefined at x is equal to 4, x is equal to negative 1, and these are vertical asymptote. Okay, so we have found the vertical asymptotes. We can write this function as f of x is equal to x over x minus 4 and x plus 1. This is same as that. If you factorize this, you are going to get this. From here we need to find horizontal asymptote. To find horizontal asymptotes, we are going to find the value of f of x as x approaches infinity, or as x approaches negative infinite. These are the two conditions we are going to use. So to find that, we'll say the limit as x approaches infinity of this function x over x squared minus 3x minus 4. What is the limit? To find the limit, I can put the limit here, but it will make much sense, but we first need to simplify a bit. So x approaches infinite, then we are going to have I can divide x on top and also x in down, x on the denominator. That will not change the value of the limit because we have divided both on top and down the same thing. So x divided by x on top divided by x squared, I'm dividing x throughout, minus 3x divided by x, and also minus 4 divided by x. This will give me the limit as x approaches infinite. We are going to have 1 on top. Here we have x minus 3, and then we are going to have minus 4 over x. We are dealing with infinite, so putting infinite here, we are going to have infinite minus 3, which is an infinite. 4 divided by infinite, this part will give us infinite, this part will give me a 0. So when you add infinite plus 0, it's infinite, so the limit we are going to have is 1 over infinite here, but we don't do that, we don't try that. The infinite is not a number, so we are going to have 1 divided by infinity, which is just 0. So when x is equal to, as x approaches infinite, f of x is 0. So vertical asymptote, horizontal is y is equal to 0. What of when x approaches negative infinite? Still we are going to get the same result. The next question we are told is to find the where the graph is crossing the x-axis and also the y-axis, the intercepts of this function. To find the intercepts, we have f of x is equal to x over x squared minus 3x minus 4. So what will happen when x is equal to 0? What is y? We are going to have 0. Y is equal to 0. So y-intercept is at 0, or the curve, the function, the graph is crossing at 0, 0. I think we can't find the x-intercept. When f of x, it is still the same point. When this part is 0, x is 0. When x is 0, this is also 0. So we only have one intercept here. So let us sketch the function using the information that we have obtained. So our function or graph is crossing at this point. We don't know how it will cross, but we know that that's where it is crossing. We found these two as our asymptotes. So I have positive 4 and negative 1 there as our vertical intercept. And also here. And our horizontal asymptote is y is equal to 0. So when y is equal to 0, we are having horizontal asymptote along that line. The next thing we should do is, I did write this function in factors form over, let me write it nicely, x over x minus 4 x plus 1. This is the same function in factors form. So from here we need to test how this function is in the asymptotes. So what is happening when we are approaching, as x approaches negative 1 from right hand side, what is the y value? So at negative 1 you pick a number closer to negative 1, but from this side we can pick negative 0.9999 is closer to that. So I put on top, I am going to have negative 0.999 divided by, here I'm going to have negative 0.999 minus 4, and then times we have 1 plus 0.999, negative 0.999. we are going to have, when you subtract those, you are going to have a positive value, something like that. This part, when you add, you are going to have negative 4.999, which is almost a 5, and on top we have negative 0.999, which is almost like a negative 1. So if I multiply a 5, negative 5 times 0.01, I'm going to have a small number down here, but on top there is a big number. So when x approaches, there is a big negative number. Down here we have a very small negative number. When I divide here, I am going to have a positive number, a big positive number. This is small divided into big, but the negatives will cancel. So we are having a very big negative number, which is just infinite. So as we are tending closer to negative 1, the graph is going up like that. That's what we have found. And then what is happening as we are approaching negative 1 from this side. So if we approach negative 1 from this side, when x approaches negative 1 minus from the left hand side, I can pick x is equal to negative 1.0001, like that. And then I ask myself to find the limit, the y value. As I'm coming this side, what is the y value? I put 1 on top, negative 1.001. Remember, these are not exact values, I just want to show you what is happening. And when I add, there's x here, when we add negative this number to that, we are going to have negative 5.0001, like that. And then we are multiplying with, when I subtract negative 0.001 from here, I add negative 1.001 with this number, then we are going to have a negative 0.0001, like this. So you multiply here, still down here we are going to have a very small positive number. This is negative, so down here we have a very small positive number. You can multiply them if you can't see, but we are going to have positive 0.0005 and then 0001. So if you divide 0.0005 into this number, you are going to have a negative infinite, a very big negative number. So as we are coming this side, the graph is going like that. But for the limits, we found that as x approaches the infinite or negative infinite, we are having y as our horizontal asymptote. So as we go towards this side, this value will go like that. As x increases, the y value becomes 0. So I can join now this. The graph will look like this. From here the graph is coming and it should cross that point, but we need to see what is happening when x approaches positive 4 from the left hand side. So when we're at 4, x approaches 4 from the left hand side. From the left hand side we can have 3.999. When x is equal to 3.999, a number closer to 4, what is the y value? Y value is equal to, we use this factorized form. You can also use this one, but it's a bit complicated. This one, the factor one, is easier to use. So I have on top 3.999. You can also add more 9s. It's an example. So if I subtract 3.99 minus 4, I'm going to have a negative 0.00, maybe 01, it doesn't matter. And then this side, 3.999 plus 1, we are going to have 4.999. You can add more 9s, there is no problem. This is almost a 5 times 0.0001 times 0.001, and then so we are going to have almost negative 0.0005, something like this. And then when we divide into this number, the number on top is big. So when I divide the 0.00 something, I'm going to have negative infinite like that. So as we are coming to 4, as we are coming this side, we have found that we are having a negative y value, infinite value here. So when you come this side, you're having this, the graph is going like that. What is happening when x approaches when x approaches 4 from the right hand side? From the right hand side we can pick x is equal to 4.900001. Then we go on our function. I'm finding the limit y 4.0001 divided by, I subtract 4 minus 4.001. I'm going to have a positive value 0.0001 times, I add a 4.001 plus a 1 here, plus a 1 here. I'm going to have 5.001 like that. So when you multiply this number and that, you are going to have 0.00050001, which means we have a very small number down here. When you divide a very small number into a big number, you are going to have an infinite, but in this case it's positive infinite. So as we are coming towards 4 from this side, the graph is going up like that. But remember, there is this one where we found as x approaches infinite, we are going to have y is equal to 0 as our horizontal asymptote, meaning our graph will go like this. Now let us join all these to make one graph. So this side I have to join this to that, and this one will be like that. So at the end we are going to have this graph as a graph for this function f of x is equal to x over x squared minus 3x minus 4. So that's how we draw graphs like this one. Alright, this question came from, she wanted to know how to express this function in a partial fraction, this function in this expression in partial fraction. So since this cannot be is unfactorizable, if this is unfactorizable, then the partial for this is ax plus b divided by the same thing here, x squared plus 4. This is linear, then we are going to have plus c over x minus 2. From here now we do cross multiplication, so or in short you can add this side, so 5x minus 4 over x squared plus 4 x minus 2 is equal to, when I add this side down here, I'm going to have x plus 4 x squared plus 4x minus 2, then x plus b x minus 2 plus c times x squared plus 4, like this. So the denominators are the same, we can equate the numerators. So 5x minus 4 should give us ax plus b times x minus 2 plus c x squared plus 4. The first value, we get the first value when x is equal to 2, because this will be 0. So when x is equal to 2, this side I'm going to have 10 minus 4, that will give me 6, is equal to this part, this is 0, everything will be 0. And then c times 2 squared, we are going to have 4 plus 4, we have 8. We divide to find the value of c. C is equal to 6 over 8, and 6 over 8 is just 3 over 4. That is the value for c. We find the remaining values. To find the remaining values, we can try to expand. For example, if I want to equate the constants, this side, the constant I'm having is 4, is equal to, when I multiply, when I start expanding, this times that, we are going to have ax squared, this, and we are going to have x, this, we are going to have x somewhere, but this times that will give me negative 2b, and then plus, from this side, the only constant that I'm going to have is 4c, and we know the value for c. So from here, we are going to substitute the value for c. So we have, by the way, 2 is common, I can reduce this by dividing it 2, then I'm going to have negative 2 is equal to negative b plus 2. Let me not do that, because the 4 will cancel nicely, rather than we start this is equal to negative 2b plus, then I have a 4 times 3 over 4, like this. So the 4 and the 4 will go, then I'll remain with negative 4 is equal to negative 2b plus 3. This one goes this side, we have negative 7 is equal to negative 2b. So b is equal to negative positive 7 over 2. We want to find the value of a. The value of a, let us try the coefficient of x. So the coefficient of x, we are going to have 5 is equal to this times that we are going to have negative 2ax, b times that plus bx. Here there's no coefficient of x, so 5 is equal to negative 2a 5x, so the x will go negative 2a plus b. We know the value for b. This is negative 2a plus 7 over 2. You take the 7 over 2 this side, we have 5 minus 7 over 2 is equal to negative 2a. From here we are going to have 10 minus 7 over 2 is equal to negative 2a. We have 3 over 2 is equal to negative 2a, and when I divide I have 3 over negative 4. So we have got the values. Now we can go and substitute them in our partial fraction. So f of x minus 4 divided by x squared plus 4 times x minus 2 is equal to negative 3 over 4 x plus our b 7 over 2 over x squared plus 4 plus my c 3 over 4 divided by x minus 2. This is our partial fraction for this expression. So that's how we can solve that one. Alright, this next question came from Onel. So she wanted to know whether how to express this function in partial fraction. So the first thing we need to know, this is a repeated factor and this is not factorizable. So what we are going to do, this question is similar to the previous one, but since the first part is repeatable, then we are going to have a divided by x minus 1 plus b divided by x minus 1 squared, and then we are going to have this part is cx plus d over x squared plus 8. From here we can do what we did